You are performing a right-tailed z-test for a population proportion. If alpha equals 0.01, find the critical value to 2 decimal places. Now this is a test for a population proportion, so we know we'll be using the normal distribution. Because it is a right-tailed test, I'm going to put the significance level on the right, which is 0.01 in this example. So that means over on the left we've got 0.99. So what we need to do to find the critical value is find the z-score that has 0.01 to the left, or the z-score that has 0.99 to the left. Same thing. So I'll do this two ways. One, looking at the normal distribution table, and then one using the spreadsheets. Okay, so this is similar to if you're performing a left-tailed test, but since we're on the right, we just have to do that trick where we subtract 1 from it, subtract the significance level from 1, and that's how I'm getting 0.99 in my example. So on the table, I'm going to look up 0.99 because the normal table tells us probabilities to the left, not to the right. The other thing to point out is that because it's a right-tailed test, my critical value should be over here on the right. And indeed, since we're looking up such a high probability, 0.99, then it should be a positive z-score on the right-hand side. So it looks like my z-score is 2.33. That's the closest I'm going to get to 0.99. I'm really using 0.9901. I could also split the difference between 2.32 and 2.3. So my z-score there would be 2.35, or I could use the z-score 2.32 for this probability or this significance level. Because 0.99 is so close to 0.9901, I feel comfortable just using 2.33. The homework shouldn't care either way. Now, if you didn't want to use the table and you wanted to use a spreadsheet, we will use the norm.s.inv, which takes a significance level, or in general a probability, and gives you the z-score with that probability to the left. So notice I'm putting in 0.99 because that will be the probability to the left of the critical value that I want. And indeed, it gives me 2.326. So, but to 2 decimal places, I would have 2.33.